Parallel combination of capacitors. Let us consider three capacitors C1, C2 and C3 are connected in parallel with each other with an external source of potential V. In order to explain this, what I'm going to do, I'm going to consider this information to draw a figure. So here is the figure where you can see C1, C2 and C3 are connected with an external source of potential V. Now, since capacitors are connected in parallel, then the charges flowing through these capacitors are Q1, Q2 and Q3 respectively, and sum of all the charges will be the total charge provided by the external source V. So we will write, let the potential difference across each capacitor is V, and the charge on each capacitor is given as Q1 is equal to C1 times V, Q2 is equal to C2 times V, and Q3 is equal to C3 times V. The total charge Q flowing through the circuit is given as Q is equal to Q1 plus Q2 plus Q3. Now let's substitute the value of Q1, Q2 and Q3 from here. And if we do that, we will write Q is equal to C1V plus C2V plus C3V. Let's take the common term, which is V. And if we do that, we will write Q is equal to C1 plus C2 plus C3 times V. Let the total capacitance across the circuit is given as C is equal to Q over V. Now let's substitute the value of Q, and if we do that, we will have C is equal to C1 plus C2 plus C3 times V over V. Now V can be cancelled out because V is the common term, and if we do that, we will have C is equal to C1 plus C2 plus C3, which is basically the total capacitance of the capacitor in a parallel combination. And this is how we'll define the combination of capacitor in parallel.